and it's a real honor to introduce you a member of our community. He's been with us in Codemotion Madrid. He will be with us tomorrow with a masterclass, but today, just for you, please, a huge round of applause for Manuel Pais.
Buongiorno. I promise I won't try to speak any more broken Italian. That's all I got. But it's really a pleasure to be here at this amazing conference. And today I want to talk to you a little bit about playing Tetris with cognitive load. So I'll explain more about cognitive load, but hopefully you know what Tetris is, right? The game. Who here has played Tetris at least once in their lives? Okay. Most hands are up. That's good. I don't feel so old. That means you've also played Tetris. So, my name is Manuel Pais. I'm one of the authors of the book Team Topologies that was published 5 years ago. And briefly, what we try to do, both me and the other co-author have a software engineering background with different roles over time. We try to apply the same principles from software engineering to the way we organize teams and how teams interact for fast flow. And one of the problems that we see time and time again is people and teams feeling like this, right? I think all of us at some point have felt this cognitive overload. Our head is so full, we feel like we cannot move. What do we do next? What's the right priority? What skills do I need to learn? All these things, right? And so maybe that's partially one of the reasons why you're here. Obviously, you want to learn and network and meet people, but maybe also you need a little break from your day-to-day work, possibly. And it turns out you're not alone, right? This study from end of last year found that nearly 1 out of 2, or over 1 out of 2 IT professionals cannot relax after their working day. They're overloaded, they cannot sort of have good family time or time with friends. Also, a study from last year found that nearly 1 out of 2 professionals experience burnout. So burnout is not one specific state, it's actually a set of symptoms. So most people working in IT and technology suffer from some of these symptoms, right? So these are problems that we need to address. And we need to understand better what is driving these sort of issues. And if we go back 5 years, John Cutler, who is quite well known in the product domain, he said, great digital products emerge from empowered, fully cross-functional teams. This sort of seems like, common sense today. But actually, when we dig into this, what does this mean, fully cross-functional teams? What's the impact on the individuals working on those teams? Maybe that helps to explain a bit why people feel overloaded, right? So we're going to dig into that. But I wanted to first present kind of one of the key patterns in team topologies for fast flow is strongly influenced by DevOps and lean movements, where we found that if you have teams that have end-to-end ownership of some service or some stream of value to your customers and to the business, that team will be in a good place to make changes very quickly. And also, if they are responsible for the runtime, so when we're talking about build and run teams, they will be able to monitor and get quick feedback on the system or service they run. What are the problems? Are the users actually using the features we're providing or not? What is the next thing we should do, right? So from a purely flow perspective, ideally we would want this type of teams, right? That can take the requirements, that can understand the customers and the users and make all the changes to the service or stream until it's available to those end users, right, in the runtime. This is sort of an ideal, again, that we've found through DevOps principles of fast feedback loops. If the team doesn't have to hand over the work to other teams and we minimize dependencies, then we'll get faster loops, right? So what we're trying to achieve here with this type of teams is a fast flow of value, where value doesn't mean we're having a feature factory where we're just putting out more and more features. Value means we actually understand if those features or changes are being used. If we're trying to change user behaviors, are we able to do that? Are we reaching the business goals or not? This kind of thing. So we need the full feedback loop to understand what we did and what we provided that is actually achieve the goal and the value, right? It's not just getting features out the door. And so we need these fast feedback loops from our running systems or services as well, right? So these are some key principles if we want fast flow of value. But then this is the question: how do we achieve this fast, safe, and sustainable flow of customer value? Where fast, yes, we want to reduce the lead times. We want to be able to go from an idea or a request and be able to deliver that very quickly. But then also safe, whatever that means in your specific context, whatever regulations, controls we need to have in place, but those need to go together, right? We need to have speed, but also safety. And then in a sustainable way. So sustainable means teams are able to keep that pace and they're not having that feeling of overloaded all the time, right? That's not sustainable. So we can't just crank up the feature factory and say, well, go faster, do more, because that's not going to be sustainable, right? What we want is a regular, steady pace of fast delivery of value. And to do that, something I often see lacking is teams need to have a clear mission. If we have a clear mission, that's going to help us focus on who are really our customers. What are the priorities we should be addressing? What are the things we should not be doing because that's not aligned to our mission? I don't know if people saw the Tetris game, the Tetris movie, sorry. Anyone saw the movie? A few people? I think it was pretty good. It's a bit exaggerated, like most Hollywood movies, but this guy is like an American guy trying to get the rights of the Tetris game, which was invented in Russia in the 80s, for distribution in the Game Boy, which is at the time was this big revolution. And so this guy had a very clear mission. Throughout the whole movie, that's his purpose, and he sticks to it, for better or worse. So when teams don't have this clear mission, what tends to happen is they sort of drift between, now this is the priority, and now this is the other priority, and now we have these other customers, or we have internal customers and external customers. So they're sort of in this constant motion, and that is not sustainable either, right? And the other thing that we need is then to have a reasonable cognitive load in our teams. And I'll go into more details, but essentially, we cannot have that overload all the time. We need to have, obviously, challenges, and people want to learn and improve and get better. So it's not that we're always reducing cognitive load, but we need to keep it sustainable, right? And that means from a software architecture kind of point of view that each service that one team owns should be small enough for the team to have the capacity to understand, build, run the service, and also evolve the service over time, right? So those streamlined teams, we need to be careful in terms of the size of responsibility they have and the size of the software they are responsible for. So where does the Tetris come in? Let's play a sort of Tetris game, but now let's look at Tetris as cognitive load on teams. And by the way, last year was the first time someone was able to finish the Tetris game and actually get to the end. Was a teenager in the US, so that's him like going crazy that he finished the Tetris game. But now let's do a slightly different version. Let's say the canvas where the pieces come in is the cognitive load on a streamlined team, right? So there are different pieces that are going to come in, different skills and capabilities that the team needs to handle. If we're talking about a software-focused team, we need to understand the architecture, infrastructure, security. So these are different types of pieces coming into the work of the team, right? And then there's a lot more. just, obviously coding, CI/CD, all the frameworks we might be using, etc. And all these things are still building the solution in the right way. So assuming we know what we should build. And then if you look at how do we actually know if this is the right thing to build and is this achieving the business goals and delivering value to customers, there are a lot of other skills that you need to bring into these stream-aligned teams, right, for fast flow. So this helps us build the right solution, identify are we actually achieving the goals and the things we're expected to deliver, right? Not just that we're doing it in the right way, but we're building the right thing. So then we have more pieces coming into the Tetris game, right? User experience, we need to understand about product management, maybe we need to improve our SRE skills. Obviously today, Gen AI is also something that's coming into a lot of teams' sort of work. I'm not an expert at all. I think there are very good talks in the conference about Gen AI, but if you think about it just from a perspective of the load on the teams, yes, it's supposed to help with productivity, allow us to create faster, but it's also changing, in a way, the role of us as technologists from being creators to being more of evaluators of potential solutions, right? Using Gen AI. Is this a good solution? Is this safe? Is a safe solution, ethical solution? Is this something that's maintainable? And so on, right? So it kind of changes, introduces more cognitive load on our teams, and so on. So we have all these pieces coming into our canvas, into our heads, and we can very quickly get into this cognitive overload. And the game is over. But we don't want the game to be over, right? So then we need to understand better, okay, what really is impacting the cognitive load on the teams and the individuals. So cognitive load is actually defined by John Sweller, who is a psychologist, as the total amount of mental effort being used in the working memory. So he defined this at individual level, right? So if you've worked with people focused on design, usability, then they usually are pretty aware of this cognitive load issues for your end users, right? The people using the applications or systems that you develop, how do we reduce their cognitive load, make it easier for them to do the task or get the job that they need done using our service or our application. But if you think about a team developing those services or applications, a team is a group of individuals. It's a lot more than that, but it starts as a group of individuals. So there's a cognitive limit as well on a team, right? Which is the sum of the cognitive capacity of the individuals. Now, this might not help you too much, just the definition, but then when we actually go into what are the different types of cognitive load, that can give us better hints as what should we do to reduce and control cognitive overload. So it turns out there are 3 different types of cognitive load, and they're not, let's say, isolated in our brains, not like we have a part of a brain doing one and the other part doing the other. They're sort of mixed together. But there is intrinsic type of cognitive load. So this is related to the skills you need for your work, right? So for people who are developing software and applications, whatever your tech stack might be, maybe use Node and React and MongoDB or whatever it is, those are skills and knowledge that you need to have at a sort of very good level, right? Because that's what you do on most of your days. And you're using those skills to actually deliver the solutions for your end users. So if we don't have the knowledge or we don't have enough experience at the moment, our intrinsic cognitive load is going to go up. It means we're spending our working memory. How do I do this? How does this framework work? How does this language work, etc. And in general, we have good ways to address high intrinsic cognitive load through, can be just training, can be mentoring with more senior people, pair programming, or even mob programming. All of those can help address high intrinsic cognitive load. And then we have extraneous cognitive load, which is more related to the environment where we work. So common example is Kubernetes, right? That is, if we expose that kind of complex tooling to the software delivery teams, and they have to know a lot of the details around how do I actually deploy my service in this platform, how do I run it, how do I scale it, etc., that might be increasing typically the extraneous cognitive load, because now we're dedicating a lot of our capacity and our brains to understanding this complex thing, which is not directly related to the solution to the customer or end user problems. But extraneous is not just about tooling, can be also the processes we have in place in our organization, can be the dependencies we have on other teams, all these things that we need to keep in mind and sort of manage internally to be able to deliver the solutions we're trying to build for our users. And then you have germane type of cognitive load, which is when we're actually focusing on the business domain, when we're actually focusing on the problem space and the solution space, right? So when we understand these different types of cognitive load, that means we should expect to minimize or reduce the intrinsic and extraneous cognitive load so we can make more space for the germane part, for the things for the effort when we're actually focusing on building solutions to our customer problems. So when we're trying to address the problem of having too much cognitive load in the teams, the first thing we need to do is make that more explicit. What are the things that are driving cognitive load up in our teams? There is a challenge, though. We cannot measure that directly. We cannot, put a wire to our brains and say, well, I'm at 120% usage of my cognitive capacity. Maybe that would be interesting, but we cannot do that. So what we need to do is look at the drivers of cognitive load. What are the things that are influencing the load on the teams? And if we're looking at the drivers, we've done a fair amount of research and work around this after the book was published to really try to understand what are some of the common drivers of cognitive load. And so we found 4 groups or clusters of drivers. One has to do with the characteristics of the team, right? What are the roles? What is the size of the team? Do we have clarity on our mission? All these kind of things are within this sort of group of drivers. A second group has to do with the actual characteristics of the work. Do we understand our customers? Do we have the right sort of metrics to understand what success looks like when we're working on this service or stream, and so on? Number 3, what are the practices and processes that we follow, right? Are those helping us, or are those causing us to spend a lot of our capacity just to understand those processes and manage them in our team? And finally, how is the work environment and tools? So it's interesting that a lot of teams that I talk to, they tend to focus mostly on the tooling part because that's kind of the more visible, I think, aspect of this. We don't have the right tooling, or it's too complicated, or it doesn't perform properly. But the work environment is also, do we have the right environment if we're in the office for us to do our best work, or do we have the right sort of remote working ability if that's how we do work better as a team, and so on, right? So these 4 areas give us a pretty good broad view on what might be different drivers of cognitive load on our team. We've also developed this tool called Temperature based on this model and the research we've done so that teams have a systematic way they can assess cognitive load, because it's not going to be going down all the time. Sometimes it's going up, sometimes it's going down. What we want to do is assess what's happening and have a better idea of what is the impact of different decisions on the cognitive load of the team. But you can also run this as a sort of internal survey, right? If you understand those 4 areas of cognitive load drivers, and we have information about that on the website, on temperature.com, so you can look into it and see, okay, these are the things we should be asking about, asking our teams about to understand where their load is coming from. Like I said, the challenge, another challenge, that cognitive load keeps changing. If we are reorganizing teams, if we're changing roles, or if we're adopting new practices in the teams, their cognitive load's probably going to go up at that time, right? Even if we're introducing, for example, an internal platform which is supposed to help reduce cognitive load, if it's not done in a way that actually simplifies the life of the teams, then we might be increasing cognitive load. So there's sometimes this understanding or thinking that we're always going to be reducing cognitive load, but actually it's managing it over time, right? So we need to measure continuously and set realistic expectations on cognitive load variation. So if, like I said, if we're introducing a reorganization of some teams, responsibilities, and roles, we should expect for a period of time their cognitive load is going to go up. So they will not be able to deliver as fast as before, at least for a period of time until they get used to this new reality. So once we understand better what are the drivers of cognitive load in our teams, and we can sort of assess them on a regular basis, then we can look at what can we do to reduce cognitive load. And one thing is related to the architecture and sort of the sizing of the responsibilities of the different teams. So we should limit the size of the software services or products to the cognitive load that the team can handle, right? So to me, this should be a primary concern when we're talking about architecture, responsibilities of different teams, is what is the size that is reasonable for this team? And again, that might change over time, but we should have some sort of baseline that is reasonable. If we don't, if the team is responsible for software that is too large for them to really understand it well and be able to evolve and change it in a rapid, safe way, then if you look at the key metrics of high-performing teams from the book Accelerate, which I highly recommend if you haven't read it, they found that these 4 key metrics are strongly correlated to high-performing teams. But if you have software that is too big, you might try to make changes very fast, but then you might be taking a lot of risks, right? Because we don't know the impact of making this change. Am I going to break other part of the application because I don't know it so well? So we might increase speed, but then our failure rate is going to increase. We're going to have more failures. If we have problems in production in our service, it might be more difficult to diagnose, understand why is the service failing? Why is it not responding as we expected? Because we don't know exactly how it works and what are the different parts of the service that are involved. So essentially, if software is too big, then we're probably going to have lower performance. The other sort of side effect, in a way, is that if we limit the size of the services or parts of the system that the teams are responsible for, we get to what you see on the right side, which is sort of a team-first software subsystem boundaries, where if you think about Conway's law, for example, that says that we are going to have a strong relation between the way teams are organized and communicate and the software architecture that we're able to build, then we would like something like on the right side, where it's not just having teams with clear services and responsibilities, but also the size is not varying too much. So on the left side is what we often see when we don't think about cognitive load, is that some teams have a very big responsibilities, other teams have small, there will be parts of the system that no one's responsible for, there's no ownership, and so on, right? So team-first software size is another one important way to address cognitive load problems. The other thing we can do, we should do, is think about, okay, what are maybe different teams and interactions that we should have in place to address cognitive load. So I'll explain that in a minute. So a topology is the way different parts of a system are arranged or interrelated. So when we're talking about teams, we're saying how different types of teams are related to each other and how they support each other. So we talked already about stream-aligned teams. These teams with end-to-end ownership of a service or a stream of value, could be a user journey or a specific user persona within a larger product. There are different ways we can define the streams, but whatever that is that provides value to end users, we have a team that has end-to-end ownership, from understanding the requirements, understanding the users, and making the changes and putting them in production, and monitoring, and so on. This is, as we saw, our ideal for fast flow. We would expect most of the teams to be stream-aligned with this end-to-end ownership for fast flow. But we still have the Tetris problem, right? We still have, okay, that means all these different capabilities and skills in the same team, and that's going to overload us. And that's why we need other types of teams. So we define 3 supporting types of teams, if you like, that are also critical for the success and for fast flow. The first one is an enabling team. An enabling team is usually a small team of experts in some domain that the stream-aligned teams need help with. That can be anything, really. Could be automation, could be SRE, could be architecture, etc., where we need to help stream-aligned teams gain those capabilities. So they reduce the learning curve to acquire capabilities by the stream-aligned teams, and they also reduce this common need for shared experts. Like, we only have a few experts in this domain, and then we should have them teach and mentor the other teams rather than executing the work, because they're always going to be a bottleneck then. If only these 3 or 4 people know how to do UX or know how to do deployments or what have you, they're going to be a bottleneck for delivering value. There's an interesting example from Adidas. So Adidas has a very strong platform engineering group within their digital services area. And they do a lot of interesting stuff, but one thing that stood out for me is that they expect their platform teams to spend almost half of their time in what they call platform advisory and community, which is essentially type of enabling work. So they understand that it's not just about providing the technology and the services, it's actually helping the teams learn how to use it, onboard, and find out how we simplify those services so they're actually helpful to reduce cognitive load and to help those teams go faster. Really interesting stuff if you're interested from the Adidas platform engineering teams. So when they expect to spend the other half of their time then actually doing the new services, features, etc. in the platform. So when we think about the Tetris game, it's almost like if we have a good platform, if we have a good enabling teams that help us learn the skills that we need to play the game, if you like, then we are able to move the pieces faster and get to, disappear the lines in the game faster because we're able to move things around more easily with the skills that the enabling team is helping us acquire. And then we have the platform teams, which obviously the idea of a platform, internal platforms, has been around for a long time. The key difference from a team topology's perspective is the goal of the platform teams is to provide services that reduce cognitive load and accelerate the stream-aligned teams, right? So we're shifting from, in the past, the focus is platforms to manage technology and to simplify the management of the technology. And now we're focusing on simplifying the work of the stream-aligned teams, right? Which might mean we might need to do things that are more complicated in the platform so that we simplify the usage of the platform by the stream-aligned teams. So seems like a small, but it's actually quite a big difference. And when we talk about platforms, I like this definition from Evan Butcher, because we need to have a common definition to understand what we're talking about. So digital platform means a foundation of self-service APIs, tools, services, but also the knowledge and support around it, which are arranged as a compelling internal product. Meaning it should be something that we offer to our internal teams, that they should have, as much as possible, the option to use it or not. Because if they decide to adopt it, it's because it actually helps them, right? It doesn't increase cognitive load, it reduces it. You can think about this almost like the platform is kind of a startup inside your organization. You already know who your target market is, are all the internal teams that could use your platform, and you should be able to have very fast feedback and conversations with your target users or potential users, right? So it's almost like finding what is the right product for our internal needs, which means, obviously using a lot of third-party tooling, etc. But then, what are the right abstractions? What else do we need to do to make it easier for our teams to achieve their end-to-end ownership? So having a good digital platform doesn't mean that the dependency goes away. We do, as Streamline teams, depend on the platform to do different things, depending on what type of platform we're talking about. But what we're doing is moving from the blocking dependencies. And by the way, if you have a platform, but the requests come in through tickets, that's not self-service. It's still a blocking dependency, right? Where we need to wait for the platform team to answer our ticket. What we're talking about is a self-service approach, where the teams can pull the things they need, whether it's deployment pipelines or monitoring dashboards or service level indicators, whatever it might be that the platform provides, we need to be able to consume in an autonomous way. So then the platform can be anything. We're usually often talking about infrastructure type of platforms, but it could be a design platform where we provide artifacts and guidance so the teams can be more autonomous and do the design work by themselves to some extent. They're not going to be experts, but if they can do 80% of the time, we know how to build the interface and build the design that works well enough, maybe that's a good thing. And the other 20% then let the experts focus on those more complicated use cases. It could be a business capability platform, right? Where we're pushing some common functionality into this platform so all the teams can use it and they don't have to worry about the internals. We need to be careful not to push too much into this type of business capability platform, because that might mean the depending teams then become sort of blocked when they need to make changes to that capability. So it should be only things that are pretty stable in terms of business capabilities. Interestingly, a few years ago, if you're familiar with the State of DevOps report, that's an annual survey of thousands of teams, which tries to identify those correlations between what is typical in high-performing teams, especially within DevOps, right? Those surveys have been running, I believe, for at least 10 years, I think more than that. And that's where those key metrics for high-performing teams came from as well. But so a few years ago, they run a survey which was more focused on this idea of team topologies, interactions, and they found that highly evolved firms use this combination of streamline teams and platform teams as an effective way to manage cognitive load at scale, so that we can push to the platform the type of extraneous cognitive load that should not be in the product or streamline team's responsibility. So in terms of the Tetris game, is almost like with a good platform that actually has the right services and abstractions, some of these pieces don't even come into the game, right? We don't have to worry about all the details about how this monitoring service works. We just use it to be able to get the results we need. And finally, there's a fourth type of team called complicated subsystem team, which is sort of a exception, if you like. We shouldn't see many of them, but sometimes we need them to build and evolve a part of a system or a service which requires specialized PhD kind of knowledge. So these are very specific situations. For example, if you have a face recognition type of module within a larger service, that is probably too complicated for the Streamline team to be the owners of that sort of complicated module, right? But we want to keep this to a minimum as much as possible. But the analogy I have with the Tetris is like if we're trying to, for the Streamline team to manage this complicated subsystem and develop it, it's almost like 10 different pieces coming in at the same time, right? It's almost mission impossible. So we talked about this type of teams, and in that sense, we're looking at a more static view, a structural view of this team of teams group, right? But we also need the dynamic part, and that's where the interactions between teams come in, because things are changing all the time. They're dynamic. We're not having those 4 types of teams doesn't necessarily mean we're doing the right things to address the challenges we have. So we need to understand when do we need to collaborate, which in our view is a very specific thing where 2 teams usually are working together to find a common solution to a problem, or they're finding better ways of working, or they are trying to reduce some blocking dependency because maybe the other team has some ownership that we would like to have in our team as well, or some capability. And then you have X as a service, which is typical for platform teams. We're providing services to the rest of the organization. Are those mature enough with the right level of documentation, easy to onboard so that we can actually help those internal customers? That would be X as a service. And then facilitating is typical for enabling teams, but could be between any 2 teams. Typically, one team that is more experienced, has more knowledge than another. We can facilitate knowledge to the more junior team. I often get this question or this remark. Many people who are working inside a team, they will say, well, we cannot change the team types and the structures, right? Because that's usually outside of our domain of responsibility. But you could, inside a team, at least you could start here. And this is a very important part. Like, how do we clarify the interactions with other teams? When should we collaborate? Are we collaborating for the right reasons? If we're trying to provide a service, is this actually something that can be consumed almost like if we were AWS, for example? Has the right documentation, is easy to understand, has examples, etc., as well as the support by our team, right? So as a team, this is something where you can start even without needing sort of any kind of permission, right? And this helps us also to, or I would say, the interaction modes should be well defined. Like, why are we doing this interaction? When is it happening, and for how long do we expect it to happen, right? And this is going to help us also plan our work, plan what we're doing, and our interactions with others. You can use something like what we call a team API. Somehow define your interface with the other teams. Hey, here's how we prefer to communicate. Do we use Slack, or do we prefer to use email or Jira or something else? When is a good time to contact us? What kind of interactions we're expecting to have with these other teams, right? So it's sort of exposing to the rest of the organization how is our interface as a team. So it's a good starting point, even if, yes, you cannot always change kind of the structures and the types of teams. But you can, as a team as well, think about, are we more of a kind of platform or more a streamlined team? What is missing for us to be more streamlined, if that's what we should be doing? That's another thing I often hear from teams is that, oh, we think we're platform, but also streamlined, and maybe we're also complicated subsystems, so probably that's too much. You need to at least start to raise awareness that we're doing too many things. And we can have this sort of visualization as well, right? What are the teams? How are they interacting, and why, right? Is there some facilitating going on because there's a gap in the knowledge or skills of some teams? What kind of services exist in some sort of internal platform, and so on. So, as we saw today, cognitive overload is a real problem for many teams. I would say most teams in software delivery. And so if we start by making it more explicit, understand the drivers, then we can start to take better decisions, and we're able to assess, are we actually improving and reducing cognitive load? We can look at, is the software sizing adequate for the team capacity? And then we can look at the topologies as another key aspect of managing cognitive load at scale, right? It's not that we're always reducing, but we're helping teams focus on the germane side of their responsibilities. After this keynote, I'll be around, happy to chat, and there's also going to be a panel at 4:30 on kind of how team topologies has evolved after the book was published, if you're interested, what new patterns have emerged, what are some industry examples of applying these ideas. So I think that will be pretty cool. And tomorrow there's a full-day masterclass that's going to be happening. If you're interested, you can talk to me as well afterwards, and I can tell you a bit more. And that's it. Our main site is teamtopology.com, where I try to publish as much as possible industry examples, helpful techniques to apply these ideas, and just any kind of resources. So check it out. And I hope this was useful, and happy to chat afterwards. Thank you so much.
Thank you, Manuel.